Hi everyone. And this episode is special to you because I'm going to go over example 4 from lesson 7.1. Okay, so 7.1 is all about the Pythagorean theorem, and we know the Pythagorean theorem can be used to find missing sides in right triangles. And we all kind of have memorized Pythagorean theorem as being a squared plus b squared equals c squared. I like to think of it as leg squared plus the other leg squared equals the hypotenuse squared. Okay, but in my previous episode, I didn't go over this example because I saved it for our in-class time together. However, if you weren't in class, well, you might be curious as to how it was done. Okay, so let's do that now. So the problem says a giant California redwood tree, 36 meters tall, cracked in a violent storm and fell as if hinged. Okay, and that's what the picture is showing. The tip of the once beautiful tree hit the ground 24 meters from the base. Researcher Red Woods wishes to investigate the crack. How many meters up from the base of the tree does he have to climb? So looking at our diagram, they're showing us that the lower leg of this right triangle is 24 meters. The vertical leg is x. So my question first is, how would we represent the hypotenuse? So we don't quite know exactly how long the hypotenuse is. We do know that the tree was 36 meters tall. And this part of it has subtracted that vertical part remaining. Okay, so like here. But it was once 36 meters tall. So this whole part here was 36. And then this is the part of the tree that fell and became the hypotenuse. So it's whatever remains of the 36 after you deduct x. So hypothetically, if this were 10, then the hypotenuse would be 36 minus 10, so it'd be 26. Okay. I can use Pythagorean theorem here, even though there seems to be more unknowns than we're accustomed to. Okay, but the Pythagorean theorem says leg squared plus leg squared is hypotenuse squared. So I'm going to do that. I'm going to be like, well, one of my legs is x, so x squared. And then the other leg is 24. And then the hypotenuse squared, or the hypotenuse is 36 minus x, but then I do need to square that. Okay. Now, 36 minus x, quantity squared. Insert another blank page. So my advice is to write it twice, because 36 minus x squared is the same thing as 36 minus x times 36 minus x. So I can multiply these two quantities together using FOIL, or I can make a table of products. But FOIL. So the F of FOIL stands for the first term. So if I go 36 times 36, I get 1,296. O is for the outside terms. So that would be 36 times negative x. So negative 36x. I is for the inside. So negative x times 36 is negative 36x. And L is for last. So negative x times negative x is positive x squared. I can combine like terms, and that would just be these guys in the middle. And so I would have 1,296 minus 72x plus x squared. Okay, so I'm going to go and I'm going to write that here. So we just had 1,296 minus 72x plus x squared. Right. Over here on the left, that's a little bit more like direct. I have x squared plus 576. So I want you to compare left side to right side. What do you notice? Yes, there is an x squared on both sides. So if I were to like go and try and get them onto the same side, they would just like cancel each other out because I'd be like minus x squared, minus x squared. So yeah, the x squares are completely canceled out. Okay, so what next? Yeah, I could subtract 1,296 from both sides. So let me write down what that looks like now. So now we have negative 720 equals negative 72x. Yeah, right. So we would divide both sides by negative 72, and we get that x equals 10. Okay, which that's kind of funny because in my hypothetical scenario earlier, didn't I say hypothetically, let's say it's 10, right? And what do you know? It's actually 10. 10 meters, that is. That's how many meters up the tree our researcher is going to have to climb, 10 meters. And so that's the Pythagorean theorem with a little bit more algebra than usual. And that's how Backer breaks it down.